Calculus AB, section 5.1, page 3. On page 2, we were finding the area underneath y equals x squared from 0 to 1, and we looked that we couldn't use any of our geometry formulas because, again, the curvature on y equals x squared is not the same as the curvature on a quarter circle. So that leads us very nicely into the fact that we have to estimate area because we can't find those exact areas of non-geometric shapes. And the method that we're going to use to do this area approximation is called RAM, which stands for the Rectangle Approximation Method. RAM, Rectangle Approximation Method. And there are 3 different of these rectangle approximation methods. The first one is LRAM, which stands for left hand heights or left side heights. RRAM stands for right side heights. And MRAM stands for midpoint heights. The first example here is to find the area underneath y equals x squared for x between 0 and 2 using 4 rectangles and LRAM. When we do this, the first thing that we want to do is to draw a graph . And we're going to make a rather large graph of y equals x squared from 0 to 2. Here's y equals x squared. Here's 2. All right. Can't find my ruler. All right. Use my phone. The first thing that you want to do is line up, take that ending point, that 2, and take that up to the curve. Right there. And then kind of shade in lightly. Now, shade lightly if you have colored pencils or just a regular pencil, shade lightly. This is the area that we want to find. We're going to shade lightly because we're going to draw stuff inside of this shape, and we want to make sure that we can still see it. All right, now we are going to use 4 rectangles, so we'll need to divide up this section or this base down here into 4 equal pieces, which splits that in half at 1 and a half and 3 halves. And we'll take each of those and line those up to the function. All right, coordinates, so it's easier for you to see here in a couple minutes. That point right there is 1/2, comma, 1/2 squared, 1/4. This right here is at 1, 1. Here is 3 halves, comma, square that 3 halves, and we'll get 9/4. And this point here is at 2, 4. All right, now there's our 4 sections we're looking at. We do not have 4 rectangles right now. We have 4, almost looks like a trapezoid, but this isn't linear. Remember, this is curved. So what I'm going to do is I'm going to kind of number off my sections. Starting right over here, here's the first section, second section, third section, and fourth section. And we want to do LRAM, which is left-hand heights. So what we're going to do is we're going to start over here at number 4, and we're going to choose the left-hand side of that section. The left-hand side of that section is right here at 3 halves. Where that hits the function, that's the height of the rectangle, so we'll clean off that rectangle. Third section, right in here, the left-hand side of that third section is happening at 1. Where that hits the function, that's the height of the rectangle. Likewise on section 2, left-hand side, where that hits the function, here's the height of that rectangle. And this first section over here, left-hand side, well, that's right at 0, 0. So the height of that first rectangle right there is, in fact, 0. Once we have those rectangles drawn, then we can go ahead and find that area, or actually an approximation. So we'll say the area is approximately equal to this first rectangle, which is 1/2 wide times a height of 0, plus second rectangle is 1/2 wide times its height, and its height is determined right here by this point, which the y coordinate there is 1/4, plus third rectangle, 1/2 wide times its height, and the left-hand side of that third rectangle hits this function up here at a height of 1. Here's the height of the third rectangle, plus height of the fourth rectangle, or width half times height of the fourth. Fourth rectangle is 9/4. And when we clean this up, then we have 0 plus 1/8 plus 1/2 plus 9/8. 1/8 and 9/8 is 10/8, which simplifies to be 5/4 plus 1/2. 5/4 is 1 1/4. 1 1/4 plus 1/2 is 1 3/4, which you could write that as 7/4 or 1.75, either one. That area under that curve is approximately 7/4 units squared, or 1 3/4 units squared. By looking at this picture, these rectangles, if we sum that area, you should see that that is an underestimate of the actual area. Okay, please join me on page 4 for MRAM and RRAM.